Welcome back, everybody. We are in Newton's second law today. Newton's second law is dealing with force and acceleration, and it's a easy formula. F equals ma. So mass times acceleration is force. Force divided by mass is acceleration. Force divided by acceleration is mass. All right, so here's our first example. Shelley the skater, total mass of 25 kilograms, is propelled by a rocket power. Now that's important because you have to have a force acting on a mass to accelerate it. If you just were to skate, push off, once you're rolling, the only thing that is controlling you is gravity, and you would just be going in a straight constant speed, and then the friction of your wheels would probably even slow you down. But she's got a jetpack, so that's a force, and that force acting on a mass is going to accelerate Shelley. Okay, so complete table 1 as long as there's no air resistance. We're ignoring that. So if she has 100 newtons, so we need to know what her acceleration is. So I'm going to solve for acceleration. Acceleration is force divided by mass. So the force, or her mass, is going to be 25, right? 25 kilograms. And her force is going to be, in this case, 100 newtons. Now let me rewrite newtons as the other way you can do newtons. So let me put it over here. 1 newton equals 1 kilogram times 1 meter over seconds squared. So meter second squared is acceleration, that's A. Kilogram is mass. So 1 kilogram times 1 meter per second squared equals 1 newton. So what's going to happen if I were to say that she has 100 newtons and I cancel kilograms into newtons, then what's going to happen is this goes away and my answer will be in meters per second squared, and that's what I'm asked to find. Okay, so 100 newtons divided by 25 kilograms is simply 100 divided by 25 is 4 meters per second squared. How about 200? 200 divided by 25, it's twice as much. This is 8 meters per second squared. And what would cause 10 meters per second squared of acceleration? All right, so I'm looking for force. So I'm going to rewrite this. I've got force equals 25 kilograms times 10 meters per second squared. So that's going to be 250 kilogram meters over second squared, which is the same as saying 250 newtons. So how about this? It has a constant 50 newtons of resistance. All right, so I've got the force is acting towards Shelley, okay, of 50 newtons, and she has resistance, which is acting backwards. So 50 is going to cancel out 50. So if I have 50 acting forward and 50 acting backwards, she's going to have 0 because they're going to cancel out. If I have 50 acting forwards, or 100 acting forwards and 50 acting backwards, it's the same as having 50 newtons of force. So let's do it again. We have 50 newtons, that's my force, 25 kilograms, that's her mass, times acceleration. What would the acceleration be? It's going to be 50 divided by 25, which gives you 2 meters per second squared. Okay, how about 200? 200 minus 50 is going to give you 150 newtons divided by 25 kilograms. So the kilogram cancels with the kilograms, leaving you meters per second squared left, and that'll give you 6 meters per second squared. Okay, let's go further. Block A, on a horizontal friction-free table, I'd love to have a friction-free table, is accelerated by a force from a string attached to block B. Okay, so you've got a frictionless pulley and a frictionless table. So whatever this weight is pulling on A. Okay. vertically and drags A horizontal. Both blocks have the same mass. So B and A have the same mass. Right? Neglect the string's mass. The string actually is going to have a pull on it too, but we're going to ignore the string's mass right now. Okay, so here are the questions. The mass of the systems A and B is. Okay, so if A and B have the same mass, then an m is a mass and 2m is twice the mass, I would choose 2m because I've got the 1m and another m here. They're identical m's, so I have two of them. So the mass of the system. The force that accelerates the AB is the weight of what? What's accelerating both of them? See, this one is accelerating down and this is accelerating out. What's causing it? What's the force acting that's causing it to move? It's the weight of B. Okay, it's the weight of B by itself. The weight of B is what? Now remember, weight, I think you actually should remember this. Weight is equal to its mass times the acceleration of gravity. Okay, so hopefully that's a choice. There it is. It's mg. Acceleration of A plus B is less than g, it is g, or it is more than g. Okay, is it in free fall? Is it in free fall? It's not necessarily in free fall. This is in free. This is not in free fall because it's being tugged. So this is actually going to be less than gravity. And last question: if use A to show that the acceleration of A plus B is a fraction of g. Okay. Well, what is acceleration? Acceleration is, well, go back to what you memorized. F equals ma. Let's solve for A. A equals F over m. What is F? What's the force making this move? The force making this move is mg. That's weight. So we're going to have we'll just replace that by mg. That's the force. And then what is the what's on the bottom? M. Okay. Well, how much m is there? There's this m plus this m. So it's a total of 2 m's. Okay. So this is 2 m's. Well, I've got m on the top and m on the bottom, so they can cancel. So acceleration equals half of gravity. Okay, half of gravity. So it's going to be less. That's why this was less than gravity. This is showing that it's a fraction of gravity. So I'll just say, look down here. Force equals ma, A equals F over m, mg equals 2m, m's cancel, A equals g over 2. It's half of gravity. All right, great.